Dear viewers, today I'm gonna show you the SiC MOSFET based 1 kilowatt bidirectional DC-DC converter developed by National Infotech. This is the schematic of bidirectional converter, and this is the door which we have applied the gate pulses supply 5 volt and ground supply, and here is the output of sensors output voltage, current and ground, and here is the driver status. If it is working fine, then it is shows green, red, ready, and if some fault are there, this red LED will indicate fault, and this is the reset button. So this is the bidirectional converter HPM module. Okay, so now we will discuss about the schematics. Okay, so in the bidirectional converter there is two mode. First mode is buck mode and second mode is boost mode. Okay, so if everyone knows the buck converter and boost converter. So in the buck converter schematics, you can see first the switch is appear. Okay, then diode is appear, inductor and capacitor and load. Okay, so there here we have 4 connectors. Okay, first 2 connectors here and 2 connectors here. If you have working with the buck converter, okay, then you have connected input voltage, input supply here, and the load is connected here. Okay, so it is working as a buck converter, and here you can see there is 2 switches there. Okay, and 2 diodes is there. Okay, so if you are working with the buck converter and this switch is turned on, okay, so you can apply the PWM pulses to this switch. Okay, and at that time this anti-parallel diode D1 diode is conducting, and you at that time you have applied the ground pulse, or you can turn off this switch, continuously turn off this switch. So this anti-parallel diode is conducting at that time of buck converter. So likewise this you can apply the gate pulses to G1, and you can apply the 0 volt to G2. Okay, so now schematic is switch, diode, inductor, capacitor, and here you have connected the load. Okay, and if you have working with the closed loop system, then you want to sense the voltage and output voltage and current. So you have sensed the voltage, output voltage here, and output current of buck converter you can sense here. You can see here is the I1 sense. So if we are working with the buck converter, then I1 sense, you can sense current, you can sense from the I1 sense port, and voltage you have get the output from the V1 sense. So you can see here on the door V1 and I1 is there, sensor output. So at buck converter mode, voltage, output voltage, the output side voltage, load side voltage we have sense from here, and current, load current we have sense from here. Okay, and here you can see the G1 and G2. Okay, so G1 means this switch. So at the buck converter mode, this G1 switch you have turn and turn off, means PWM pulses you have given to the G1 and G2. Okay, so at the buck converter mode you can apply the G2 as a ground. Okay, so you can see here, so on the door you have applied the PWM pulses to G1, and G2 you have applied the 5 volt. Okay, so internal some arrangement are there, so which will convert this 5 volt into the ground, and this ground voltage is applied to the G2. Okay, so on the door you have applied the 5 volt, and some internal arrangement are there, so which will convert this 5 volt into ground, and you have applied G2 as a ground. Okay, so and you have connected the 5 volt and ground here to drive the driver circuit. Okay, so at the buck mode you have connect like that, and here you can sense the voltage, input voltage. Okay, so now another mode is boost mode. Okay, So again two connector is here. Okay, so you can see here is the boost mode. So at the boost mode, this two terminal as an input terminal, okay, and this two terminal as an output terminal. Okay, so here you can apply the voltage, input voltage, and here you have connected you have connected the load. Okay, whatever load it is, you have connected here. Okay, so in the boost circuit, first inductor is the switch. Okay, then diode is appear, capacitor and the load. Okay, so in the boost mode, now you have see the in the boost mode you have applied the PWM pulses to G2, and you have turn on turn off this switch. Okay, so you have applied the PWM pulses to G2, and in here at the boost mode you have just conduct the D2 diode. Okay, so you have to apply the G1 pulses as a 0. Okay, so here you can see at the boost mode you have applied the PWM pulses to G2. Okay, and here at the G1 you have applied the 5 volt, and internal some circuit are there which will convert this 5 volt into the ground, and this ground is appeared at this switch. Okay, so 0 is appeared at this switch and PWM pulse is appear here. Okay, so turn on turn off the switch. Okay, so schematic is completed. So inductor, switch, this diode is conducting when boost mode is there. Okay, and capacitor and load. Okay, so at the time of boost converter, you when you are working with the closed loop system or open loop system, you want to sense the output voltage and current, and this voltage V2 and I2 is appearing. Okay, so you have see here at the boost mode output voltage is V2 sense and I2 sense. Okay, so if you are working with the closed loop system, then this two current is more important, voltage and current is more important for you. So V2 sense and I2 sense. So from here you have to take output, sensor output, so V2 sense and I2 sense. Okay, so this is the some schematics of the SiC MOSFET based bidirectional converter. Now in the next video we have working with the boost converter. Okay, thank you very much.